Hi, it's Terry Dennery of the MathWorks. So we're doing pretty well, but basically all we can do is make it go up, and I think we can make it come down too. But this video we're going to work on making it rotate and maybe move it in all three directions. Yeah. So, anyways, we're going to add a little bit to this, and really kind of key to this is really the ability to rotate it. And once you rotate it, you can essentially get a component of that thrust that's kind of moving in a X or a Y direction, right? And it all kind of comes down to differentiation of the thrust for each of the four propeller units and differentiating their speed specifically. So anyways, let's get into this. Go ahead and shut that down. Here's our models. We left it in the last model or the last video. And so, we talked about this, kind of trajectory planners really turning into the flight controller. Maybe we'll even call it that now, flight control, right? And here's our trajectory. And so pretty much everything else, I'm going to put into its own subsystem. I messed that up. Let me see if I can undo that. Okay. And so I didn't want to grab that bus selector. Okay, that's better. All right, so let's just start moving some things around. The basic idea is get this a little cleaner. I'd say that these default sizes really don't work for me. They're a little too big, and I kind of like that size, and so I'm going to match it with this one. So I think, select that first and select this, go to Format, and match size. Nope. All right, select that, go to Format, match size. All right, again, compress this as much as I can so that when I hit the space bar, it all looks bigger, right? And I thought I called that the controller, but I guess I didn't hit enter. So let's do this again. Flight control. Okay. And that this is pretty much everything else, essentially the quadcopter with all the motors and electro and mechanical things. And you either call this the plant or you call it maybe the quadcopter, right? And I think this looks a little bit better up there. Okay, I'm not going to even bother hitting the run button because I kind of know we didn't really affect any true change. We've just kind of made things a little clearer, and perhaps we've set up our means for partitioning the work a little bit more easily. And so the control and software people will operate more in this box. And all the hardware, and I mean like mechanics and motors and stuff like that, they'll kind of work in this box. All right. And so, you know, again, the point of this video is that we can kind of rotate it and that we can move in the X, the Y directions, as well as the Z and all kinds of stuff. So our work really is going to occur here in the flight controller, at least most of it. All right. And so the basic idea right now is that we've calculated a ascent, that's what our trajectory is right now, and we calculate the thrust, and then we deliver that thrust uniformly through all four propeller units. And so the basic gist of this is that I'm going to even make this a little smaller because we're going to reuse it a little bit. Let's make it like that. Okay. And that we're going to have four of these. I think we're going to keep that trajectory, and maybe I'll just kind of keep the bus and everything down here for a moment. And the idea is that this is a nice unit as is, that's saying, well, I'm a propeller, all I do is spin and I generate thrust according to a command. So we're not going to modify that at all, but we're going to give it two types of thrust, right? And so one is that we're going to acknowledge that this is really ascent thrust. It's all about making it go up. Maybe I'll even come in here. I think I will clean this up a little bit. And I will call it ascent thrust. space, come back out, right? And I gotta make this block a little longer now. Okay, and the general gist of what we're gonna do is we're gonna add that ascent to what I'll call the differentiating thrust. And so we'll get to that in a second, right? And so it's gonna go in like that. And I think I'll even get into this right now. So I'm going to create a bus selector, no, bus creator, right? I'm going to make it the same height as this box. Do that again. Okay, that's selected. Shift key. Okay, both are selected, and now I can match height, right? And that winds up the signals real nicely for me. All right. And that this, well, we're going to keep that trajectory. I don't know why that line's so wiggly, but let's, yeah, kind of move this over this way. Let's hit the space bar, and we'll bring that down here, and we will call it XP. Right? And perhaps you know where I'm going with this is I'm going to copy this 3 times. All right. And they'll each have a different name. XN. Squeeze in an import right there. This one will be YN. And let's give myself a little more room. As well, let's make that a little bit bigger. Okay, I won't be a perfectionist. In between videos, I might clean that up and get all those lines perfectly horizontal. All right, so let's kind of put that in right there. And that this one will be YP. And I always like to click on this, make sure I got it right. And that looks pretty good. And yeah, that trajectory is right there. So the bus itself is carrying 4 buses as well as a trajectory command, right? And so here's where I'm going to be a little bit, I'll say, perhaps creative at my best, but perhaps I'll say less than fully kind of articulating the way this overall design will really work. Now, it's clear that this will happen with all 4, so let me just get that ascent thrust included, right? But it's how we're going to fill in these ports, right? So this was just kind of an idea that came to me. I think it's a decent idea. And again, I'm going to repurpose this, right? Control C, paste this in. And what's kind of good about this kind of smooth trajectory is that it's kind of on and off, you know, and the way it really is formed is really with the acceleration. You might think of it that way, that this designs an acceleration that will hit this, you know, kind of transition, right? And so what's a little bit loosely defined what we're going to do here, well, we are going to, you know, effectively start rotating the vehicle once it's at 2,000 meters. So, you know, it reaches 2,000 meters at 110 seconds. So we're going to just kind of hold that position for 10 seconds and then we'll start rotating it. And this ultimately will be a number much more precise and much more scaled according to kind of the mission that we're going to be doing, as well as the mass properties of the vehicle itself, right? And the basic idea of this is to get not the first component, but the third component, which is its calculation of acceleration. So it's a scalar signal, and we're just kind of coming up with a number that makes interesting things happen right now. And the way it works, you know, is that, well, if I want to do a Y rotation for my vehicle, it means I offset my thrusts on X, right? And so if I'm doing it, and so we are going to do a Y rotation, and so it means that I want to kind of create the moment by having positive 1,000 Newton meters added to my XP, but minus 1,000. So the overall thrust is not changing. All right, and so we get that. And I think that's pretty good. You know, and if it's not, we'll go fix it. But what I need to do now, though, is just kind of receive that modification on this side. All right, it's all kind of coming out of here. And so this command signal, I'm going to just delete the whole thing. And let's just redo it. All right, and so we have a bus delivering buses at this point now. And so we get a bus selector. Let's bring that down here. Okay, we'll line up those signals in a second. Let's double click on here and we will remove, and take the XP. Looks good. And I just send that in right there. Okay, and so we'll do that 3 more times, lining these up. I missed. Do that again. Okay, so XP to XP, that looks good. This should be XN, then it'll be YN, and then YP. Okay. All right. And well, let's try running, see how we do. Oh, I already see an error on my part. Well, let's be done in a second. Notice it goes to 120. So we got to run a little bit longer this time because it doesn't even begin rotating until the 120-second mark. So let's run it again, 150 seconds this time. It's nice it runs as quickly as it does. And so here's what I'm going to do. I'm going to go to 107. Let's try that again. 107. Resize my window, and we'll watch it arrive at that 2,000 meter position. And so we'll hold that position for 10 seconds, and then we'll get the differentiation on the thrust. I believe it's these two. There you go. And there we get that torque that drives that rotation. And with that rotation, there's a side component to thrust that can move it now in the X direction. All right. While we have this, I do want to show something that we will have to deal with regard to rotation, which is we kept our thrust magnitude the same, and therefore as we rotated it, we're no longer compensating ideally for gravity. And so we'll get into, I'll call a little bit more definition on our controls to maintain the vertical thrust at the same time we're rotating and providing a side component. All right. And so just want to do a little bit more on this one. I'll make the case that X and Y are pretty much the same idea, so I won't belabor that. But what I do want to do is the Z. All right. And Z is a little trickier. In Z, again, I got a quadcopter with my 4 propellers. It's this kind of rotation. Okay. And that all of that takes place because the propellers do have mass, they do have inertia, and as we torque off of those propellers, that we're applying that same torque to the vehicle, right? And so we can do that in a coordinated way. We can achieve that Z rotation, right? And so it turns out that for that rotation, you want the x's to be the same. So I'm going to remove the negative there, but you want the y's to be opposite, right? And I'll make that a minus. Okay, and so we'll hit run again. Ooh, I'm in error. Let's see, what's this? Oh, did you see it? I forgot my selectors. Okay, so it's essentially faulting over receiving a 3-component signal when it's expecting a single component. Looks like it's working this time. And it's already done. And let's go to, I'll go to 115 this time. All right, so it's in this vertical hold at this point. Did I get there? Oh, enter. And at 120, it should start rotating. And please excuse me for this kind of subtle thing I just chose to go for in this video. All right, but what I wanted to really show is that where 1,000, you know, well, let's see, what are we? Yeah, where 1,000 on thrust, which is directly kind of, you know, the force that's generating the moment, is good for the X and Y rotations. It's nowhere near good enough to kind of do this Z rotation. And all I'm really saying is that propellers are light and small inertia, and therefore the torque required to push off and get that rotation is a little bit harder, right? And so this may not be the solution that we ultimately go with, but to get something that looks interesting in this video, I will increase that to 100,000, right? And I will paste that in right there. And here I'll make it minus 100,000. Okay, again, it looks like it's running pretty well. And I think I'll get us to 115 again. And we'll continue that. And we'll see what that much larger kind of thrust difference. Okay, and notice it is going up now because we've added thrust to get this to work. And yeah, but I think what I'm excited about at this point is that I ultimately I know how to apply torque to this vehicle, and combining that with the thrust, the one directional thrust that's available with the quadcopter, that we will be able to do what we need to. All right, thank you.